Assalamu alaikum. Hello everybody. This exercise concerns the proof of the solution that un and vn are adjacent. Un is equal to 1 plus 1 over n power n, and vn is equal to 1 plus 1 over n power n plus 1. We remark that Vn is equal to un times 1 plus 1 over n, which is greater than un or equal. This is Vn. First, second, un is non-decreasing, and Vn is non-increasing. We will show this, but before, I would like to remember that that the geometric mean is less than or equal to arithmetic mean and greater than or equal to the harmonic mean, such that the arithmetic mean for a set of points is equal divided by the number of points, and the sum from e equal 1 to n xe. Suppose that we have n elements. If xe are positive, then geometric mean is equal to the nth square of x1 times x2 xn, and the harmonic mean is equal to n divided by the sum from a equal 1 to n, 1 over xe. The same case for xe positive. Here and here we need to suppose that xe are positive, but in the arithmetic mean this doesn't mind. So remember please this formula, and be aware that this result can be proven. So we can prove that. We use some property of exponential, for example, or convex function to prove this result. So I will use geometric mean, arithmetic mean to prove that un is non-decreasing, and geometric mean with harmonic mean to prove that vn is non-increasing. Remember this formula. I will put the exercise in this type. If we consider 1 as an element times 1 plus 1 over n power n, how many elements do we have here? We have 1, and here we have n elements. 1 plus 1 over n, this is the first element. 1 plus 1 over n, second element, and till n. We have n elements plus 1 element. We have n plus 1. So we will take the nth plus 1 root. This is less than or equal to the arithmetic. The first is 1. The second we divide by n plus 1 element as we take the n plus 1 root. This is the first element, and the elements 1 plus 1 over n are repeated n times. So n times 1 plus 1 over n. which is equal, this one is equal to 1 plus 1 over n plus 1. Then the nth plus 1 root of this element is less than or equal to 1 plus 1 over n plus 1, which means that 1 plus 1 over n power n is less than or equal to 1 plus 1 over n plus 1 power n plus 1. We take to power n plus 1 to cancel the nth plus 1 root. This means that un is less than or equal to un plus 1. This means that un is non-decreasing. This first. Second, we keep the same technique, but here as we have n plus 1, so we take here n plus 1 and here n plus 1 plus 1. N plus, this is greater than or equal to what? This is greater than or equal the harmonic formula, n plus 2 element, n plus 2 element. The first element is 1 over 1, which is 1 plus how many elements of the kind of the type 1 plus 1 over n? We have n plus 1 element. So we have n plus 1 element of the type 1 over n. But actually this, we take n here, we divide, we have here n, so we have n plus 2 over n plus 1. This is equal to 1 plus 1 over n plus 1. So if we take to the power n plus 2, we will obtain 1 plus 1 over n power n plus 1 is greater than or equal power n plus 2, 1 plus 1 over n plus 1 power n plus 2. This means that Vn is greater than or equal to Vn plus 1, which means that Vn is non-decreasing. So we proved the main important result in this case. Remember that un is less than or equal to Vn. Remember that we have this. un is less than or equal to Vn. un is increasing and upper bounded, so un is convergent. Vn is non-increasing and lower bounded by u1, so it is convergent. It's convergent. We take the difference between them. If we take the difference, we have Vn minus un. This is equal to un times 1 plus 1 over n minus 1, which is equal to un 1 over n. Un, it is convergent, so it is bounded. And since it is bounded, so this goes to 0, 1, and goes to plus infinity. It is non-decreasing, it is non-decreasing and bounded. It is convergent, so 1 n goes to plus infinity. This converges to limit L, and this goes to 0, so L times 0 is equal to 0. This is all. Thank you. See you next time.